Hello everyone. Based on the concepts that we have studied so far, we'll understand few programs. The first one is computing the roots of the equation ax square plus bx plus c is equal to 0. This is basically a quadratic equation, and this equation, it has two roots. You'll all know it. Correct? Now the roots can be real, they can be imaginary, or they can be equal. That all depends upon the value of your discriminant. It all depends upon the value of your discriminant. Okay? So, you have to execute this program in the following steps. The first thing is you have to read the values from the user a, b and c. So here a, b and c are called as coefficients. They are called as coefficients. There will be no solution if a and b are 0. You have to display the message and the program must terminate. The equation boils down to linear equation if a is equal to 0. So if a becomes 0 in this equation, your equation will boils down to bx plus c is equal to 0. Okay, so what will be the value of x? X is equal to minus c by b. Again, you have to print the root with appropriate message and you have to end. Otherwise, if both of these are not true, you have to calculate the value of discriminant and determine the corresponding roots. So when we determine the discriminant value, it will have three values: 0, less than 0, or greater than 0. Okay, so depending upon the values of the discriminant, we will have three types of roots. If it is 0, the roots will be real and equal. If it is less than 0, the roots will be imaginary. If it is greater than 0, roots will be real and distinct. Okay, now let us understand this with the help of few values. Okay, then we'll understand the program. Now let us take value of a is equal to 1, b is equal to 2 and c is equal to 1. Okay, so both of these are not true. Now I have to determine the value of discriminant. What is the formula for that? D is equal to b square minus 4ac. Substitute here, this becomes 4 minus both are 1, so this becomes 0. D is equal to 0. Correct? So as per our discussion, what will be the nature of roots? Roots are real and equal. Now how do you compute the root for this? Yes, root 1 is equal to minus b divided by 2a. So this will become b is divided by 2 into 1 is 2 minus 1. Roots are equal, both root 1 and root 2 is equal to minus 1. Take one more example. So you will have a is equal to 1, b is equal to 5, c is equal to 4. So what will be the value of discriminant here? B square minus 4 into 4 into 1, 16. So this will be 9, which is greater than 0. So what is the nature of roots? Nature of roots is real and distinct. Now how do you compute the roots in this case? If the discriminant is greater than 0, you will have root 1 which is equal to minus b plus square root of discriminant this whole divided by 2 into a. Okay, so substitute the values. Minus b plus square root of 9 is 3 divided by 2a is 2. Okay, so I will have minus 2 divided by 2, which will give me minus 1. So this is one of the root. So similarly, you will compute root 2. How do you compute root 2? Root 2 will be minus 5 minus 3 divided by 2, which comes out to be minus 8 divided by 2, which is equal to minus 4. Okay. Now take the last example for imaginary part. So a is equal to 2, b is equal to 4 and c is equal to 6. D is equal to b square minus 4ac. So this will be 16 minus 4 into 2, 8. Okay, so this 4 into 2 into 6. Minus 48 which is less than 0. Okay, so in this case we will have something called as a real part and imaginary part. So what is real part? Real part is equal to minus b divided by 2a. What is imaginary part? Imaginary part will be square root of discriminant divided by 2a. Okay, so on substituting the values, you will get some value for real part and some value for imaginary part. Now how do you display the roots? You will display it as root 1 is equal to real part plus I imaginary part. Okay, what is the root 2 is equal to real part minus I imaginary part. Okay, so this is the logic behind your program. Now we'll just have a look at the program quickly. So here, as you can see the program, okay, here all the variables are declared as float. Read the values from the user. If a is equal to 0 and b is equal to 0, print no solution and exit from the program. If a is equal to 0, display the equation is linear, okay, and exit. Otherwise, you compute the discriminant value b square minus 4ac. Here again you have to check the conditions. See, I've just made use of if and else if conditions here. D is equal to 0, roots are real and equal. So I will compute root 1, root 2 is equal to minus b by 2a and display it. Else, if D is equal to D is greater than 0, display roots are real and distinct. Compute the roots accordingly. Root 1 is equal to minus b plus square root of. One thing you have to remember, square root is an inbuilt function. Okay, it's an inbuilt function which is defined in math.h header file. Also, whenever you are using that exit 0 function, that is defined in stdlib.h header file. So you have to not forget to include these header files. If you don't include, then an error will be incurred. Otherwise, the roots are imaginary. You have to compute the real part and imaginary part. As I said you before, you don't have to compute it, you have to just display real part, I, imaginary part. Okay, so you will be ending the program. We'll just run and see for the same values. Enter the value for A, B and C. We just computed our values, right? 1, 2 and 1. So you observe roots are real and equal. Root 1 is equal to -1, root 2 is equal to -1. Run it once again for the other set of values. So in this case I will enter 1, 5, 4. Roots are real and distinct. We just computed -1 and -4. Run it once again. If I enter A is equal to 0, okay, B is equal to 1 and C is equal to 2. This is a linear equation with this. Now if both A and B are 0, so 0, 0, 7, I get no solution. Last, for imaginary part, I will enter 2, 4 and 6. Roots are imaginary. So observe here, real part is displayed separately and imaginary part is displayed separately. Okay, I hope you understood the execution of the program. Thank you for watching.